Let's talk about the limbic system for a moment. Anyone tell me what the limbic system does?
Movement.
Movement? Not so much? Yeah, okay. Alright, let's have a look. The limbic system. This is the area of your brain that helps you to manage, identify and feel feelings, emotions. Emotional processing occurs in the limbic system. Everything that you've experienced in your life comes through and is associated with the limbic system. You have a feeling response into almost everything you experience. So the limbic system is a complex series of areas in your brain where you process information that has an emotional component to it. A key area here is the hippocampus and the amygdala. Now, where did you hear me talking about the hippocampus earlier?
About life stories.
Yes. Hippocampus is where we process conscious verbal memory. Memories and emotions go hand in hand. So our ability to remember things often evokes emotions. So as we remember a story, we picture a person, we feel a change in feelings. Does that make sense? So this area down here in the jagged line is your hippocampus, and right on the end of it is an area called the amygdala. A-M-Y-G-D-A-L-A. Amygdala. Now, I don't speak Greek, but I'm told that the word means almond, or almond shaped. Does that ring bells? Anybody speak Greek? Nobody can contradict me.
No, but I've heard
Sounds
Yeah.
right.
Okay. So what we've got there is an almond-shaped piece of brain tissue on the end of the hippocampus, which is responsible for very primitive emotional experiences of rage and fear. Very strong, primitive survival emotions of rage and fear. And it's associated with a lot of intense emotional experience, regardless of the colour of that experience. So the amygdala is a very important part of our experience as human beings, because it shapes how we respond to what we experience. So we've got emotions and memories closely linked here. So what we remember has a feeling tag to it. Did I like it? Dislike it? Loved it? Hated it? Loved them and hated them? You know? Because our parents, we love our parents, but we can get very angry with our parents, can't we? Children, your brothers and sisters, you love them, but you can also get very angry with them. So here we have those complex feelings that we get as human beings. And the memory is associated with events that will trigger off feelings. We feel a certain way, and so we find ourselves thinking a certain way, and vice versa. Constant interplay. And the limbic system is like a band that runs around this central, old part of our brain that we call the reptilian brain. The reptilian brain is a bit like our brain stem, our core old part of our brain. And it's the part of our brain that we have in common with the reptiles. It's the part of our brain that controls our very basic physical functions, like our temperature, our heart rate, our sleep-wake cycle, all those cyclical, basic, unconscious things that you referred to earlier with the sympathetic So overlaid over that very basic reptilian brain is our emotional sense. So emotions are an important part of our life as human beings. And the reptiles don't have them. They don't have emotions the same way you and I do. Does that make sense?
Mm-hmm.
So what we then have overlaid over that limbic system is our cortex. Our ability to think rationally, to make decisions, to communicate, our language areas, so that we can solve problems and talk to each other, to think about ourselves. All of those human, higher order human functions, to be problem solvers, creative thinkers, speakers, to dance, to sing, to paint, to calculate, to be scientific. All these higher order functions that don't have anything to do with emotion, but we need to have emotions to be able to know what we love and appreciate.
Yeah. That's getting involved. The brain involved too?
Yes, absolutely. Yeah.
Do we have basically a reptile brain originally?
In the evolution of the human person,
Yeah.
there's a belief that in fact as we grew, what signified our change was the volume of our brain increasing and the complexity of the brain, the folds.
Yes.
The number of folds in comparison to the weight of the brain is really important because it signifies the surface area of the brain per volume is really important. Because elephants have huge brains, but they don't have the complexity of ours. And they don't have the frontal area, that cortex, that frontal part of our brain that makes us different to the dog. You know? My border collie, she was an incredibly intelligent dog, and she had really big frontal lobe. And as border collies do, they're very intelligent dogs. They're really good at problem solving. They'll work things out. She knew if I locked the front door, all she had to do was go around the back to get in. She quickly worked that out. Particularly if there was cat food left out. So, your limbic system is terrifically important as part of that core of our brain that enables us to feel something about whatever we're experiencing. To feel good about being here, to feel like we don't like being here, I like them, I don't like them, I feel comfortable being with this group of people. Does that make sense? So our feelings are terrifically important. This area of our brain gets a lot of challenge with dementia because it needs this area of our brain, the frontal part of our brain, in order to be managed well. In other words, we need our reasoning part of our brain as well as our feeling part of our brain. Because if I'm just full of fear or rage, how am I going to act? Yeah. Then I'll act out of it. But if I've got a rational part of my brain that says, hang on a minute, there's no actual saber-toothed tiger, I don't actually have to flee. People are not out to get me. Then I can reason about what I'm thinking or feeling. I can think about what I'm feeling, and I can work out a way to say, all right, my feeling's not giving me good information about what's actually real, I'm going to do this instead. So we can manage it. But if your dementia affects your ability to think rationally and solve the problems, then sometimes how you manage the feelings is a bit disorganised and unpredictable. So you can tend not to be able to manage the feelings as efficiently as you might have in the past. And some of your normal defences that enabled you to function clearly, see, some people deny that they've even got feelings. You know, their best friend dies, but don't feel sad. But then they go out and drink all week.
Yeah.
So what you've got there is denial and displacement. Two defences, but if you've got dementia, you might not be able to keep that sort of defensive structure in place. So you might actually get eruptions of these feelings in the person's behaviour because the defences don't keep them behaving as they did in the past. So you get personality style change as well. So what we can see is that the biological change affects the way the person actually starts to behave. Here's the amygdala sitting on top of the hippocampus and the limbic system coming around here like two horns of a ram. Imagine that into the temporal lobe. Yeah, right there in that temporal lobe area. There's one on either side of the person's brain.
Does the limbic system shrink
in post-traumatic stress disorder, it will shrink in volume, particularly the hippocampus will shrink in volume. There's been some good research with Vietnam veterans with PTSD where the volume of the hippocampus shrunk by 25% over a period of about 10 to 15 years. Yeah. These are people who have chronic PTSD, who cannot function normally in society anymore without becoming overwhelmed with fear constantly. They're the guys who were saying they would operate point in a patrol. They'd be the first guy out front. You do that for 2 years. And I did know a chap who operated, he was point for 2 years. They rotated, but he was in and out of patrol for 2 years in the jungles of Vietnam. So what he was living with was chronic arousal, constantly. So his body got used to the arousal. So New Year's Eve, he could not be anywhere where there were crackers or anything like that. So, and the smell of old boots would just remind him of the jungle. He couldn't go to nurseries because of the humidity.
So to be on edge, in other words, or constantly.
Because it's triggering.
Exactly. He worked as a bus driver in an aged care home at one stage, and they went to a nursery, but he just couldn't function, and they had to get somebody else to drive him home. It's interesting. Despite his very generosity of spirit, very generous guy, completely disabled by this experience. And a real problem for a lot of people that goes unnoticed for many years. And they'll self-medicate with alcohol to try and manage that arousal to keep them within reasonable limits.
With sociopaths, is there a difference in that sort of area of the brain? Like people who murder and don't care?
Yeah. They don't get any of this. They have underfunctioning fear and rage. So they don't, it's not that they don't get any, it's just that they don't have feelings.
They're more detached.
The way that you and I might. There's another little area of the brain, it's in what they call the prefrontal cortex, which is just here over your right eye, a little area about the size of my first joint on my finger, just in the right hemisphere, where we develop a conscience or an awareness of the impact of our behaviour on another person. And they have a very small area of that. So they can do things without much awareness of the impact of that on somebody else.
Can it be sort of in response to environment, or can it just be more like that sometimes?
Well, that's a really good question, and I think philosophically there's been a debate about whether that's which of those two answers is true. So it depends a lot on who you ask. People will tend to fall into one of those two camps, or they'll sit squarely in the middle and say it can be both. And in certain circumstances it might be more the upbringing of the person, and in other circumstances they might say, well no, it's more clearly biological. If all members of the family turn out to be murderers, it could well be learned, or it could well be biological, that there is in fact something missing there that should be. So it is rather interesting if you track down the influences on what makes a person the way they do. Some would say, well, it's very early parenting that happens in infancy, and others would say, no, it can happen at any time in the person's life. But when we look at brain plasticity, you would think, well, there's a lot of possibility that it is environmental, that the experience of living, growing up, infancy, being mothered in a particular way, there will be lots of reasons why it might turn out the way that people do. This is just another little graphic of the amygdala with the hippocampus. The amygdala is right on the end of the hippocampus there, all sitting within the temporal lobe. And the hippocampus comes around and is... Hippocampus is... it's named that for the Latin word for seahorse. Don't ask me why. But I think it's the shape of it. There's something about it that reminds whoever was first describing it that, oh, that looks like a seahorse. Okay. Just a few things around the hippocampus. The hippocampus records the spatial and temporal dimensions of experience. Where was I and when did it happen? So if I've got a memory, then my hippocampus will enable me to know where and when it occurred. Now you'll notice that quite often people with dementia will have an ability to tell you a story, but it will be out of time and out of place, perhaps, or out of sequence. So they'll know the narrative, but it lacks a context. The hippocampus gives us context. It tells us where and when. It categorises and stores incoming experience. It helps us process what we experience into, did I like it, did I not like it, who was there, where was I, etc. The hippocampus also holds short-term information before storage or forgetting. Now thankfully we forget most of what we experience. Because if you stored everything you experienced, you would just be overloaded with everything that comes into your brain. And if you think about it, if you watch Big Brother, you really don't want to remember most of that. Or anything else much on television. You just don't want to remember it. You want to remember the important stuff. And this is what the hippocampus does, is it helps you to store it for short term. In other words, what was that phone number you gave me yesterday? Or what's the code to get in? Anybody remember?
I forget it again in February.
Yeah, that's right, by February you'll have forgotten it. But that's where your short-term memory keeps it in place. It's often called working memory. How long do I need this information for? Okay, I need it later today, so I'll store it knowing that I can retrieve it later today. But if somebody gives you a phone number and you've got to enter it straight away, knowing that you're not going to need to recall that again, then you probably won't. So your brain knows how long it needs to hold the information for, and it puts it somewhere where you're going to be able to get it back in the appropriate time. It's necessary for explicit memory. And here we come across two different types of memory. Explicit memory and implicit memory. Explicit memory is what you know you know. Implicit memory is what you know, but you don't know you know. Does that sound complicated enough?
I'm writing it down, but it doesn't make clear.
Explicit memory is what I'm aware of that I can remember. My name, my age, concrete information, things about myself, the address of where I had to come today. All that's explicit. Implicit memory is things like knowing how to get dressed. You can take it out of implicit memory and make it explicit. You think about doing up your shoelaces.
Yeah, swimming. Once you've learned it, you've learned it.
Once you've learned it, and it becomes implicit. Implicit means I don't have to think about it to know it. I just know how to do it. It's like driving a car,
Learning a phone number.
learning a phone number. Well, no,
Sometimes.
that's explicit.
Oh, okay. Even though
Even though it's become
Where are
automatic.
you
You
with
have to actually
explicit?
recall it.
Yep.
What did you say? You know,
Things you know, you know.
okay,
That's
that's explicit.
explicit.
Yeah.
Implicit memory is what you are not aware of knowing.
I
Okay.
don't know what you have.
Yes, you
You
don't know
don't know what you
really
know.
Yeah,
Ah,
exactly.
That means you are not aware of even you know something.
Yes.
Ultrasounds.
It's what you might call unconscious knowledge. Is that making sense?
Yeah.
Okay. Now, what will decrease most in dementia is explicit knowledge. Implicit or explicit memory. Implicit memory will often stay for longer. In other words, I know how to get dressed even though I couldn't tell you where I live. Because knowing where I live is explicit for me. But implicit knowledge is what I'm not aware of knowing, but I can still do it. Like getting dressed or driving a car. So the hippocampus is necessary for explicit memory. If the hippocampus is damaged, then what we'll end up with is behavioural disinhibition. Disinhibition simply means a lack of control, uninhibited. Behaviourally uninhibited. Disinhibition. So the hippocampus interacts with our frontal lobes to help us to control our behaviour. But we know, remembering, that the hippocampus is the area of the brain that is first affected and most dramatically affected by Alzheimer's disease. So remember that while we go through these descriptions. The hippocampus is a really important area for us in relation to Alzheimer's disease. Hyper-responsive to external stimuli. Hyper-responsive to external stimuli just means the person is easily affected by what's happening around them. So when you think about the dementia experience that you've had, it really brings it back to you that in fact the surroundings, the way the person is treated, the way the person is spoken to or ignored or excluded or devalued has a much greater impact on them than it might for you and me. If their hippocampus is not functioning effectively, then it will have a much greater effect on their emotional state. Serotonin is important in proper functioning of the hippocampus. So serotonin is an important neurotransmitter for what? We've described it perfectly today. Depression. Depression and motivation and all of those behaviours associated with or symptoms associated with depressed mood, depression as a syndrome. Lack of motivation, difficulty thinking, difficulty learning.
So that should be also one of the most important medications.
An antidepressant?
Yeah.
Well, interestingly, the occurrence of depression is much greater in people with dementia. So it makes sense that treatment of depression with antidepressants in the context of dementia, yes, should go hand in hand. Yeah.
Or interesting to look at something like we touched on before, the melatonin. Is that what
Yes.
that helps with serotonin? So doesn't it?
Not necessarily.
Serotonin cycle or something.
Serotonin will also influence sleep-wake cycle,
Yeah.
but melatonin is the major neurotransmitter that has an influence over sleep-wake cycle.
Okay.
Stress induces loss of hippocampal cells, and this is coming to that information I was talking about earlier in relation to PTSD, which is chronic stress. Stress induces loss of hippocampal cells. So the person will not be able to, if they're living in a chronically stressful situation, they will have smaller hippocampal volume, which makes it more difficult to learn, to control their own behaviour, be motivated, etc., and are much more likely to be depressed. An inability to evaluate incoming stimuli, is it dangerous or not? The person with post-traumatic stress disorder is not able to critically evaluate whether or not it's dangerous, the situation I'm in currently. They just simply go for, yes, it's dangerous. And so they react as if everything that they experience is dangerous. They can't critically evaluate whether it's dangerous or not. Does that make sense? Because to critically evaluate it, you've got to have your frontal lobes functioning, helping you to think about it, to reflect on it. Now the amygdala, which sits right at the end of the hippocampus, evaluates the emotional meaning of incoming stimuli. Is it risky for me or not? Do I like it or not? Is this good for me, or do I need to get angry about this? Or do I need to feel sad about this? Has this hurt me? Have I felt like I've lost something here? If that's the case, I'll get sad. If I've been hurt, then I'll get angry. It assigns a free-floating feeling of significance to sensory stimuli. In other words, this is important for me. What's happening now is important for me. So the amygdala starts to come into play. And then it integrates memory images with emotional experience. So I can see what it was like, or I can smell what it was like, or I can hear what it was like. And this is often what veterans from war will report, is they could hear the sound of battle, or they could smell the jungle, they could smell the blood, or they could see the image of people, aspects of the situation. A fellow with PTSD from being up at Rabaul off the coast of New Guinea, when a volcano exploded there some 20 years ago. He was involved, he was there in the village, in the township of Rabaul, when the volcano went up, and it spewed ash all over the town, so everybody had to be evacuated, thousands of people. And in the course of it, the rascals came in, and the rascals were gangs of young fellows who were really dangerous, and they had machetes, and they were looting. And he hid under a bed, and all he saw of this gang of rascals were the boots, really thick black army boots of these guys. So he's under the bed, and he's experiencing it, and the fearing was quite extreme. So now he's back in Melbourne, and when I saw him, this was nearly 20 years ago, he was sitting in a cafe down in St Kilda, and somebody walked into the cafe wearing the same boots, and he just had to flee, just had to leave the cafe. He couldn't stay. The hyper arousal. In other words, his amygdala was firing, saying, this is dangerous. Completely irrational. No frontal lobe action, just amygdala. Does that make sense? It guides emotional behaviour of fear and rage. And so we find the amygdala dominates and often prevents the frontal lobes getting into action, to the point where the person can't think rationally about what they're doing. It overwhelms rationality, and it causes fight or flight. And when you think about it, if there's a real risk, that's exactly what you want. You don't want to stop and think about it, you want to do something about it. Either protect yourself, fight, or flee. You want to run fast. So you want to be able to do that very quickly. So this system of the amygdala and your adrenal glands sitting on top of your kidneys are designed to gun you into action. And that's exactly what you need to do if you're faced with a life-threatening experience. The trouble is, we often don't have life-threatening experiences. We don't have it often enough. But occasionally in life it will present itself to us. Does that make sense? But the amygdala here, in a person with post-traumatic stress disorder, which interestingly is very similar to the sort of arousal you can sometimes get in dementia, that sort of arousal causes the person to act in ways that are pre-rational. They're not thought through, they're simply survival. It makes excellent sense for the person to function like that when there's a real threat. But in post-traumatic stress disorder, the person will act like that even though there is no external stimuli, or there's a part of it, like the vision of the boots, that was enough to stimulate the fear reaction as though the rascals were there again, whereas in fact they weren't. Now I'm going to skip over this because it's very complicated, but it's a way for us to understand it. I'll give this to you in a one-page. I'll print that off as a one-page. You get a much better view of it. This is the role of memory in the recall of traumatic experience. It just helps you to understand how understanding those old memory cues and the information that goes with memory, in other words, the sensory pieces, how does it smell, how does it look, how does it taste, how does it feel, how does it look, how does it sound, all of that goes together to create an experience. And you'll find there explicit and implicit memory, etc., and the function of dementia over on the right-hand side, and how that affects the person with dementia. So we might go over that even next time we have a look.